Hello, welcome to this video on organic reactions. The question of the day, what are a few reactions you already know? You should know at least 5. An organic reaction is classified as any chemical reaction that involves an organic molecule, and there are definitely hundreds, if not thousands, of organic reactions, but we are going to start off with a very basic list. To begin, we'll talk about substitution reactions. And if you have ever played a sport, then you know exactly what I'm talking about when I talk about a substitution. This may be a player that kind of sits on the bench waiting for somebody to tire out. Maybe, I hope not, we're waiting for them to get hurt. A lot of these sports also have time limits on the number of minutes or hours a player can play in a season or in a game or even in a week. So, for those reasons, you'll have a substitute. If you are in the theater, they call them an understudy, somebody who fills in for another person, or even when your teacher's absent, you will have a substitute fill in for them. It's kind of what we're talking about here. In this case, you are going to have some type of alkane, so a single bonded carbon chain, and a hydrogen is going to be kicked off, and some other some other atom is going to replace it. Typically, that is going to be a halogen. It's not always a halogen. It could be any number of molecules, but for the purposes of high school chemistry, oftentimes you will see it as a halogen. So in this case, we have a butane, a 4-carbon single bonded chain, and we have chlorine, diatomic, of course, coming in, and the chlorine and hydrogen are going to swap places. So you will be left with a 1-chlorobutane and hydrochloric acid. Next up is the addition reaction. And in this case, you'll have a multiple bond that is broken down / decomposed into something a little bit more simple. So in this case, we have a 2-butane, or rather 2-butene. So in this case, we have a 4-carbon chain with a double bond between the second and third carbon. And that butene, that double bond right there, is going to be broken down into a single bond between those carbons, and the chlorine is going to attach right where that double bond was, turning it into 2,3-dichlorobutane. This can happen to double bonds, and you can turn them into single bonds by attaching something new. You can take a triple bond and turn it into a double by attaching one set of diatomic atoms. Or you can take that triple bond and break it all the way down to a single by attaching on both sides. So the addition reaction can play out in a few different ways, but the real thing to look out for here is a multiple bond breaking into something simpler. The fermentation reaction is one of my favorite reactions. I really like to make bread. I think fresh homemade bread is so delicious. I don't know that there's anything more delicious than a slice of warm, fresh bread straight out of the oven. And the fermentation reaction happens when sugar comes in contact with some type of catalyst. In chemistry, we call it a catalyst. In biology, they call it an enzyme. If we're talking about making bread, then you would use yeast. Yeast is going to convert the sugar into alcohol. Bread, the alcohol cooks out of the bread. And because the oven is warmer than the alcohol's boiling point, so it just kind of like vaporizes in there. But the primary thing that's happening here is that the sugar gets converted into carbon dioxide. Carbon dioxide is usually considered the byproduct. It's not usually something that you want, but what that does is that it's going to fluff up the bread. If you look at a slice of bread, it's nice and fluffy and there's little air holes in there, and that is caused by the carbon dioxide. It is going to lift the bread. That's what makes bread rise, all that air in there. And it's a delicious reaction. Esterification, of course, is going to make an ester. The process by which this happens is a little difficult, so definitely watch my color codings going on down there. In this case, you need some type of organic acid and an alcohol. And what will happen is that the OH from the alcohol and the H of the acid are going to make water. And then the leftovers of the acid and the alcohol are going to merge together, and they are going to make an ester with that oxygen and double bonded O. If you're having trouble seeing it, I would draw this with a pencil, erase the H from the acid and the OH from the alcohol, and then see how they fit together. The double bonded O and the leftover O of the acid are going to kind of be that dividing piece between the two sides of the ester. Now, remember, the ester, you split it at that interrupting oxygen, I like to call it. The side that's all carbons is considered the main chain, and then the side with the double bonded oxygen is considered the dangle or the substituent. So that would be the ethyl, the side, the left side of the molecule in this case, and the main chain would be the right side of the molecule, which is the all carbon half of the molecule. Saponification is the reaction that is used to make soap. If you rearrange the first four letters of saponification, you get soap. It's a silly way to help you remember it. Now, we don't typically make soap this way anymore unless you are hand making soap, in which case, like, yes, good for you. I'm so excited for you. It's not necessarily the safest thing to do because you have to use a really strong base. So if you are making soap at home, it's important to be very, very careful with it. And also, don't use your cooking materials for your soap making materials. They should be different pots and pans. So soap is going to be formed from some type of organic fat. It doesn't have to necessarily be animal fat. It could also be oils like coconut oil or olive oil even. It could be the fat that is present in like goat's milk. People make soap out of lots of different things, but we're looking for some type of organic fat. It is going to be a gigantic molecule, and it is going to be reacted with a strong base, which we often call lye, but it really is just sodium hydroxide for the most part. That is going to react and form soap with a glycerin byproduct. Glycerin is just kind of like it's kind of like a very thin, watery Vaseline, if you could think about it that way. It's a carbon molecule, very thin and runny. It is often used in lotions because it's somewhat moisturizing. Next, we have polymerization reactions, and those are used all over nature, but people use them as well. So in this case, you are going to have a monomer, which is a teeny weeny little carbon molecule, one or two carbons maybe, and those are going to be linked together over and over and over again to make quite large carbon molecules, mono for one and poly for many. And this is going to be used to make all kinds of plastics. So that's how humans use it, like in the real world. But in biochemistry, you would also use this reaction for making proteins as well as making starches. Now, this one you may have already learned, and that is the combustion reaction. In the combustion reaction, you are going to have some type of carbon fuel burning in the presence of oxygen, and you are going to form carbon dioxide and water. And of course, this is fire, so the water will be a vapor. And this is sometimes considered an organic reaction because of the carbon fuel. Some teachers will teach it with organic chemistry, some teach it outside of organic chemistry. It doesn't really matter how we classify it. It's a very common reaction, so I can see it going either way. In this case, we have butane combusting in the presence of oxygen. So butane is the lighter fluid. And propane would be what you find in a barbecue grill, and octane is gasoline. So any of these organic molecules, carbon-based, burning in the presence of oxygen will result in a combustion reaction. That's everything for the introductory organic reactions for high school chemistry. Like I said at the beginning of this video, there are so many types of organic reactions. If you take organic chemistry in college, don't be upset with me for telling you that there's only 7 because we're just starting with 7. There are so many reactions, and this is a good starting place. So please make sure that if you have any questions, you leave them in the comment section below the video. Subscribe so you don't miss the next lesson. I'll see you there. Bye.